In number 39, which of the following equations best describes the preparation of chlorine? We have A as the correct option. The reaction between manganese oxide and hydrochloric acid to give manganese chloride, water, and chlorine gas is used in the laboratory for the preparation of chlorine. Questions 40 to 43. Instructions. Each of the following questions consists of a statement in the left-hand column, followed by a second statement in the right-hand column. Decide whether each of the statements is true or false. Then, on your answer sheet, mark option A is taken if the first statement is true, the second also true. The second is a correct explanation of the first. B, if first statement is true, but the second is also true and is not a correct explanation of the first. C, first is true, second false. And in D, the first is false and the second true. So in number 40, the first statement is that reactive metals liberate hydrogen gas from dilute acids. Yes, that is true. The second statement is that sodium reacts violently with water. That is also true, but that second statement does not explain the fact that is in the first statement. So we have option B. The first is true, the second is true, but the second does not explain the first. So the correct option in 40 is B. 41. Propene dechlorizes bromine water. The second statement, propene contains carbon-to-carbon double bonds. The first statement is true, propene is unsaturated, and so it would have to dechlorize bromine water. Second statement is also true, propene contains carbon-to-carbon double bond, the fact that it is unsaturated. And so the second statement is true and is explaining the first statement. So in that case, option A is correct, because option A says the first statement should be true, the second should be true, and the second is explaining the first. In number 42, the first statement says heated copper 2 oxide is reduced when a stream of hydrogen gas is passed over it. That is true. Hydrogen is a gas at room temperature. That is also true. So both statements are true, and the second is not explaining the first. So we have B as the correct option. Number 43. Anhydrous copper 2 sulfate is used to test for water. That is true. When water is added to anhydrous copper 2 sulfate, it dissolves in it. That is false. So the first statement is true, and the second is false. So the first statement is true, and the second is false, corresponding to option C. In number 44, what is the major effect of sulfur dioxide emission into the atmosphere? It leads to acid rain, because sulfur dioxide is an acidic gas. In number 45, which of the following pairs of substances is not suitable for the laboratory preparation of hydrogen? We have zinc and dilute hydrochloric acid, magnesium ribbon and dilute hydrochloric acid, calcium and water, sulfuric acid and copper metal. D, sulfuric acid and copper metal. The reason is that copper is below hydrogen in the electrochemical series, and so cannot displace hydrogen from mineral acids. Number 46, which of these contains the same number of particles? This question, you have to be very strategic. It has to do with the number of moles, because the number of particles is directly proportional to the number of moles, since 1 mole usually contains the Avogadro constant, which is giving the number of species in a particular chemical substance. So in the first part, A, 12 grams of carbon and 10 grams of sodium will never have the same number of moles. In B, we have 20 cm cubed of 0.1 molar. If you multiply 0.1 by 20, you get 2. And when you divide 2 by 1000, you will get the number of moles, because moles is molarity times volume in dm cube. So we have 20 times 0.1, which will give 2. When you divide 2 by 1000, you have 0.002 as the number of moles of sodium hydroxide. Then when you take the case of 40 cm cube of 0.05 molar hydrochloric acid, 40 times 0.5 would give 2. And 2 divided by 1000 again would give 0.002 moles. And so in B, sodium hydroxide and hydrochloric acid have the same number of moles, and so we expect them to contain the same number of particles. So the correct option should then be B. Of course, if you verify C and D, you will see that the various species, according to the information given, do not present the same number of moles. In number 47, two elements X and Y have electronic configurations 24 and 287 respectively. Identify the bond type in a compound formed between X and Y. Now, the electronic configuration of X is 2,4, so the valency would be 4 because the number of electrons in the valence shell is 4. So X has a valency of 4, and Y has the electronic configuration 287, so it's in group 7 of the periodic table, and the valency of group 7 elements is 8 minus 7, which is 1. So here we are looking at the more metallic element, which is 4. Group 4 elements are metalloids. They have their reactivity between that of metals and non-metals. So in group 4, we have 4 valence electrons, which are usually difficult to transfer due to the much energy that is needed for that process. So group 4 elements can only perform the sharing of electrons with non-metals. And since Y is a non-metal, specifically a halogen, we expect the sharing of electrons between X and Y, and usually the sharing of electrons corresponds to a simple covalent bonding. So C is the correct option. Of course, it cannot be the dative covalent bonding, which has to do with the sharing of electrons in such a way that the electron pair that is shared is coming from one of the atoms. In number 48, select a balanced equation to show the complete combustion of propane. Now we have to verify the various atoms that are involved to make sure that the number of atoms are the same on both sides of the equation. Propane has 3 carbon atoms and 8 hydrogen atoms. A reaction between propane and oxygen is supposed to give carbon dioxide and water only. That is a combustion reaction involving a hydrocarbon. And so in A, we have but carbon monoxide, which is not possible. In C, we also have but carbon monoxide, which is not possible. So we're going to be looking at the options involving B and D. Now, when you balance carbon dioxide and have 3 in front of it, makes the number of oxygens on the right hand side to be 6. When you balance water on the right hand side, you have the number of oxygens there to be 4. So 4 oxygen atoms in water and the 6 oxygen atoms in carbon dioxide. This will give a total of 10 oxygen atoms on the right hand side of the equation. And so to balance the number of oxygen atoms on the left hand side, we would need to put 5 in front of oxygen gas, so that we have 5 times 2, making also 10 oxygen atoms on the left hand side. And so the correct option will be B. In number 49, how many Faradays of electricity will be needed to pass through a solution in which 5.5 amperes of electricity are allowed to run through for 1 hour? Generally, in a question like this, we first get the quantity of electricity that is needed. It's given as Q equals IT, where I is the current in amperes, so 5.5 times the time, which must be in seconds. The time is said to be 1 hour, so 1 hour corresponds to 3,600 seconds, giving 19,800 coulombs of electricity. The number of Faradays should then be equal to 19,800 divided by the equivalent of 1 Faraday in coulombs, which is 96,000. And that gives 0.206, or approximately 0.2 Faradays, corresponding to option B. In number 50, dry ice, otherwise called Hadis, is a refrigerant that sublimes. The particles that make up dry ice are carbon dioxide molecules. Yes, dry ice is a solid form of carbon dioxide.